Thank you, Dr. Vijay, for joining.
Thank you, sir. Thank you.
Yeah. So, uh, please tell me your name and the paper ID.
Paper ID is 796
Who is going to present 796?
Vijaya Padmanabha.
Dr. Vijaya, are you there? Dr. Vijaya Padmanabha, are you there? Hello. Why? Okay. So just ask her to speak. Say hello. If you could just ask her to speak, say, so that we can. Uh,
Hello, I'm audible.
yeah, we can hear you. Yes, you're audible.
I but I cannot hear. I have a problem in my PC. Is that a
Okay.
problem?
Please start presenting. Please upload your paper. हाँ हाँ क्या बोल रहे हैं? अच्छा मैं भी भेजा फिर से.
I've shared my screen. Is it visible?
Yes.
Yeah.
Shall I start?
Yes.
Good morning, respected chairperson, distinguished guests, and fellow researchers. My name is Ariane, and today I'm presenting our paper, Face Detection and Emotion Recognition using Convolutional Neural Network. Facial emotion recognition plays a critical role in human-computer interaction and intelligent systems. In this research, we're proposing a compact convolutional neural network, or what we call CNN, trained on the FER 2013 dataset, which consists 48 by 48 pixels, grayscale facial images across these 7 emotions. Our model integrates the convolutional layers, the batch normalization, max pooling, dropout, fully connected
Aryan,
layers, as we
sorry for
achieved
interrupt.
87%.
Aryan,
We
please change
achieved
your slide.
87% of training accuracy, 70% of validation accuracy. Our findings shows that the regularization techniques that we used is significantly improved,
हाँ
although
बोलिए बताइए
challenges remain, overlapping emotions
तो
such
ना
as the
इंटरनेट
fear
नहीं चल रहा
and
था
the surprise.
Aryan, change your slide and put it in full
Facial
screen.
expressions are some.
Put it in full screen.
I cannot hear you.
I'm audible. Aryan, I'm audible. Show your PPT in full screen. Okay, good.
Should I proceed?
Yeah.
So our goal is to improve the robustness of the emotional recognition, which is on low resolution grayscale images, specifically 48 by 48 pixel. Additionally, we aim to develop a model that is efficient and suitable for real-time deployment. Current facial emotion recognition models, often with like they struggle in the low resolution images, face difficulty to recognize the overlapping emotions, specifically for feel and surprise, and frequently they're expensive. Our work addresses these challenges. The literature review, as shown, is the LPP-based text feature by Ojala, which for the facial expression, uh, even with the Krasivitsky et al. FEAR 2013 benchmark, which is the standardized benchmark, deep press net models, attentional transformer based on the 2013, 2023, 2024. And the research, despite these advances, performance drops significantly on the grayscale images, often because of it's misclassified, and there's a trade-off between achieving the high accuracy and maintaining the efficiency at the same time. Our system follows these two stages, which is the face detection. We're using OpenCV based on these methods, emotion classification using the CNN model, and we used, as I mentioned, the FEAR 2013 dataset for the grayscale images. It's classified into 7 emotions: anger, disgust, fear, happy, sad, surprise, and neutral. The techniques we've used, which is Keras with TensorFlow backend, data augmentation, horizontal flipping, and random rotation, GradCamp for the interpretability of the architecture of the CNN. Moreover, the model structure that we've used in these steps sequentially, convolutional layers, batch normalization, ReLU activation, the convolution layers to extract the features specifically, the batch normalization is to stabilize the training, the ReLU activation, max pooling for the dimensions, dropout is to regularize the pictures, fully connected layers, softmax output for the 7 classes. And this diagram explain how the process moves on sequentially. So as I mentioned before, our model achieved 87% training accuracy and approximately 70% validation accuracy. It loss decreased steadily, although there's slight outfitting. The emotions, the happy, it is 80 and up. Surprise, it's 80 and greater than. There were confusion for some of the observed emotions. The studies that we did was about these. Moving to discussion slide, which is explaining how the CNN effectively captures the hierarchical facial features, although it's low resolution image, which doesn't discriminate the power of it doesn't contain these limitations. Overlapping facial cues can cause ambiguity as
I think we lost our connection.
Yes, sir.
Era, Kha- Kha- Khazama, Al Khazama. Can you hear us?
Yes, sir. I can hear you. Can you hear
Okay.
me?
Yeah, I can hear you. Thank you. Is your name Khazama?
Al-Khuzama al-Arami, yes.
Okay, good. Welcome. So I would suggest you start. Your paper ID 797, or what is it?
No, it's 833, I think.
Okay, okay, 833. Yeah, that's the third paper. So
Or,
why don't you start? And we'll ask her to join. So you started.
sure. Let me share my screen.
Yeah. Dr. Vijay, I think we can have her with your permission.
Okay, sir. You can
That would be a good
proceed.
idea. At least our system is working properly, so we can hear and understand.
No issue.
Actually, this is my first time using Zoom, so I'm trying to navigate where.
Okay, so basically on the bottom of the screen, you can see a red type of, a green button which says share
Yes.
on the bottom thing. Click on that share,
First,
you will be able to do it.
But it,
first open your PPT on screen, then you have to share.
right.
Take your time, no problem.
First open your PPT. Khazama,
Yeah,
first
I
open your PPT.
I did open my PPT, but
And then share, go to share option, showing,
in Zoom,
yeah,
yeah, I whenever I click on the share, okay, now it's working.
then you have to select after sharing,
Yes.
select the PPT.
Right. Can you see my screen?
Yeah,
Okay. I actually have notes in the PPT, so I cannot. Let me just adjust this.
okay, move on the next slide.
Just a second, sir. Yeah, I cannot see my notes, so.
It's moving.
Yeah, it is moving, but I just cannot see the notes that I wrote in the presentation. So just give me a second, please.
Yeah, I would suggest you start, Kazama.
Yeah, but I mean, I have. Can you see the whole screen with the notes as well, or
Yeah, I can. Not the notes.
background back to slideshow?
Yeah, don't worry. We are not. We won't mind if we see the notes. Okay. There's no harm. We won't.
Sure, fine. Okay, so just,
You can proceed now.
it was obvious, right? Without the notes, right? Or
It is without the notes now.
Okay.
We can't see the notes.
okay, is it with the notes or without the notes now? Sorry.
It is without the notes. We can't see the notes. It's
All
full
right.
screen. It's wonderful.
Again, sorry for the inconvenience.
No problem.
I'll keep it short
Please
and quick for you guys. So good morning and welcome to this presentation. Thank you for the opportunity that you've given us to showcase our work. Just need to. Screen is not working. Okay. So my name is Al-Khazam Al-Aremi. I will be presenting my research titled Assessing OT Cybersecurity Readiness in Critical Infrastructures, a Global Framework and GCC applications. So we move on to the abstract. This research addresses the increasing cybersecurity risks resulting from IT and OT convergence in critical infrastructure. So the study evaluates readiness within the GCC sectors and adopt major frameworks, including NIST CSF and NIST SP 882, IEC 62443, and C2M2. The findings identify key organizational barriers such as skill shortage, IT/OT silos, and propose a hybrid framework to adopt adoption approach to strengthen the regional resilience. So moving on, operational technology systems are reasonably responsible for monitoring and controlling industrial processes. These include SCADA systems, DCS, and PLC environments. So traditionally, these systems were isolated and basically designed primarily for safety and reliability and not keeping in mind cybersecurity. However, like the digital transformation nowadays, the IT/OT interconnectivity significantly changed this landscape. While integration improves operational efficiency and visibility, it also exposes the OT systems to cyber threats. So legacy OT systems are more and more increasingly being exposed to that cyber threats. In the GCC countries such as Oman, UAE, and Saudi Arabia, we're heavily invested in smart infrastructure and industrial modernization. So critical infrastructure such as energy, water, transportation are economically and strategically vital, so making them very, very attractive to cyber targets. So we saw incidents like Shamoon on the Saudi Arabia Aramco. It was Shamoon 1 and Shamoon 2 as well. It demonstrated really the potential of catastrophic impact on OT-focused targets, targeted cyber attacks. So that despite increasing awareness, a unified and localized approach to measure OT cybersecurity maturity across the GCC remains lacking. So the study therefore focuses on evaluating readiness and identify the most suitable framework model to support structured improvements. So moving on to the literature review, in this section, we reviewed the main OT cybersecurity frameworks and maturity models relevant to critical infrastructure. First, we had the NIST CSF cybersecurity framework, which provided a high-level structured organization organized around 5 core functions, which is to identify, protect, detect, respond, and recover. It's widely adopted and useful for strategic risk management, but it is not OT specific and does not provide detailed technical controls. Whereas the NIST SP 882 offers dedicated technical. Sorry, I think I moved on. Yeah, it provides dedicated. I think I just moved on. Yes. Yeah. So whereas the SP 800 dedicated technical guidance for securing industrial control systems such as SCADA, DCS, and PLC's environment, unlike the CSF, it is highly OT focused, but does not function as a maturity model. The IEC 62443, it goes further by providing prospective technical requirements and defining security levels for industrial systems. It is considered the engineering standard for OT security. Although its implementation is very, very hard and complex, and it costs a lot of resources as well. Finally, we have the C2M2, which is cybersecurity maturity model. Is explicitly, again, it's a maturity model. It allows organizations, particularly in the energy sector, to assess their cybersecurity capability levels and benchmark improvements over time. So beyond the framework, the literature highlights key readiness challenges, which are particularly in the shortage of skills of OT cybersecurity professionals, IT/OT organizational silos, and governance fragmentation, which all of which are highly relevant to the GCC contents. Now, this study adopts a qualitative literature-based methodology, combining a structured review with comparative frameworks analysis over 40 academic, industry, and policy resources were analyzed, focusing on energy, water, and transportation sector within the GCC context. A thematic analysis was conducted to identify reoccurring readiness challenges, followed by comparative evaluation of the selected frameworks against criteria such as OT-specific maturity, capability, and regional adoption. So a cross-framework comparison matrix was developed to evaluate NIST CSF, NIST SP 882, IEC 62443, and C2M2 against criteria such as, is it OT specific? Does it have the maturity measurement capabilities, regional adoption and implementation barriers? Finally, the findings were brought together to develop recommendations, including hybrid framework adoption approach and regional specific maturity improvement strategies. So, in results, we first conducted a comparative evaluation of the selected frameworks. So the findings show that the NIST CSF when combined with SP 882, provides a strong governance and is relatively well aligned with the GCC policies, particularly when in the energy sector. However, it lacks a built-in maturity progression mechanism, whereas the IEC 62443 offers the highest level of technical depth and OT specific, but its implementation is it's very complex and costly and requires a lot of expertise, which limits its adoption. The C2M2 provides a clear maturity measurement structure, but it is currently low in visibility and the adoption in the GCC, mainly due to resources and organizational readiness constraint. Overall, the analysis confirms that no single framework fully addresses the regional needs, supporting the necessity of a hybrid framework approach. From a sectorial perspective, the energy sector as well was the highest. The energy sector demonstrates the highest maturity due to regulatory attention and investment, of course, while the water utilities and other areas lag behind because of legacy infrastructure and fragmented governance. So in the discussion, highlights that the primary barriers to OT cybersecurity improvements in the GCC are not related to the framework themselves, but rather than the organizational readiness factors. Many organizations lack strong executive ownership of OT cybersecurity, resulting in limited strategic direction and insufficient resource allocations. In addition, the shortage of skills in OT cybersecurity professionals remain a major constraint, often leading to reliance on external vendors and superficial implementations. IT/OT silos also continue to hinder unified risk management, while limited asset visibility makes it difficult to improve advanced control efficiency effectively. So as a result, a framework adoption in some organizations occur mainly at a policy level, creating what can be described as a checkbox compliance without true operational maturity. These findings reinforce the need for a hybrid model or framework approach combined with the regional maturity benchmark and targeted workforce development incentive to support sustainable cybersecurity improvements across the GCC critical infrastructure. In conclusion, the study evaluated the readiness of the GCC critical infrastructure organization to adopt leading OT cybersecurity frameworks, including what we mentioned in the slides. And the findings indicate that the energy sector demonstrates the highest level of cybersecurity maturity, largely due to the regulatory attention and investment as well. While sectors such as water and transportation remain less developed. Several systematic challenges were identified, particularly workforce capabilities, gap, IT/OT organization silos, incomplete asset visibility, and fragmented policy environments. These factors collectively limit effective framework implementations. So the analysis also confirms that no single international framework fully addresses the regional requirements. Therefore, the hybrid multi-layer adoption strategy is recommended, combining governance, guidance, technical controls, and maturity measurement mechanisms. Finally, the study emphasizes that the workforce development is the most critical success factor. Strengthening the human capital through specialized training and certification programs will provide the foundation necessary to improve the OT cybersecurity resilience across the region. So basically, this study has several limitations. I think one of which the study is based on secondary data and literature only, no direct industry reviews or field validation, limited publicly available OT cybersecurity data in the GCC. Sector coverage focuses mainly on energy, water, and transportation. There was there was limitations in that. So future direction is to do an empirical validation through case studies and industrial surveys, development of a GCC-specific OT cybersecurity model, and quantitative measurements of framework adoption impact, and investigation of policy harmonization and regulatory alignment, and evaluation of workforce development and training effectiveness. I think this concludes my presentation today, and these are the references. Thank you so much.
Okay, Khazama, Naish, your paper.
Thank you.
Can you tell what is the source of data set
The source
in your
of
paper?
Yeah, you meant the data. Yeah. So basically, the source of the data of this paper was basically a combination of the review of the frameworks, as well as papers from Scopus and industry-related papers as well, from SANS, for example, to get related papers on OT-specific cybersecurity.
What methodology you have used to provide more security compared to other researchers?
So again, it's part of the limitations. Qualitative literature.
What's your innovation in this paper?
Okay.
Your paper is review paper or invited paper?
No, it's a review paper.
Only review paper?
Yeah, literature-based research approach, basically.
Okay.
Yeah.
What methodology used?
Qualitative.
Sorry?
Qualitative.
Quantitative.
Qualitative.
Which security algorithm mentioned in your paper?
Which, beg your pardon?
Which security algorithm used?
Security algorithm? I'm not sure. What do you mean by that?
In your paper, provide a security based your paper.
Mm-hmm.
Which security algorithm mentioned?
Okay, so it's basically my paper is basically reviewing the cybersecurity frameworks and models that are available for OT cybersecurity. So it's a governance part of it. It's not a technical.
Okay.
Yes.
What mean by secondary data? You work on secondary data. What mean that?
Okay. Basically, secondary data is, in my perspective, it's data that is available to me. It's not a primary data, as in I did not, again, it's part of the limitations. You're talking about OT, operational technology. It's a very critical infrastructure. So it's really hard to get primary data from sources, basically, since it's very critical.
Okay. My Khazama,
Yes.
your name pronunciation is Khazama.
Yes.
My suggestion is ki you should put some mathematical values also in this paper,
Okay.
right? And use some mathematical formula to evaluate how to evaluate the parameter to provide a more security compared to other papers. So it's need.
I'm sorry, you were talking? I cannot hear you.
You understand what I'm saying?
Yes.
So you should mention some mathematical formula, and some mathematical values should be put in your paper.
Okay.
Need to put, right? Which describe how your innovation is better compared to existing methodology.
Okay.
To provide a more security, right? And need to focus exactly what you want to work, right?
Mm-hmm.
Okay, Baki, your job is very nice. Your work is very nice.
Thank you.
Need to improve some researchal methodology.
Of course.
Basically, you from Arabia country.
Excuse me?
Basically, you from Arabian?
Yeah,
Arabian country?
I'm from Oman. Yes.
Oman.
She's from Oman.
Okay,
All the
nice.
presenters are from Oman today.
Okay, sir. Nice. Okay,
Okay.
good luck.
Yes, thank you so much.
Good luck, Khazana.
Thank you.
Good luck, Khazama.
May I drop the call or should I still be here?
Nee, you can.
Yeah, please be here. Listen to your other co-fellows.
All right. Thank you so much.
Sir, sir, I am Ariane. For connection is like went out, so just now I joined and I left with only 2 slides. So can I explain it right now?
Yes, you can. Proceed, continue.
Okay, I'm sharing my screen. So is it visible?
It is visible.
Okay. So basically here we reach to the 5th slide, which is talking about the discussion, exactly what we did. So in the interpretation of the results, starting with the CNN, so basically this CNN efficiency captures the hierarchical facial features as we put in the data set. Then there is also something called a low resolution images limit discriminative power, and also overlapping facial cues cause ambiguity, as we know. Regarding the comparison with the prior studies, first of all, we started the comparable to standard CNN, the convolutional neural network models of the FER 2013. This is the name of the dataset, which contains 72%. Then the more computationally efficient that transformed based the models. And then we go by the compact of the design suitable for the real-time completion. So here, basically, the CNN efficiency captures the hierarchical the hierarchical facial features, but the lower resolution images, basically, it will limit the discriminative power. Then we are having overlapping the facial, because as I said, because of ambiguity as seen of fear or, for example, surprise. And our result comparable to the standard CNN models. So we compare to transform-based models. Our approach is basically computationally efficient and suitable for the real-time application. Then coming to the conclusion. So basically, regarding the summary of the findings, we started developing compact CNN for the FER 2013 dataset. We achieved a planned trade-off between the accuracy and also the computational efficiency. Regularization also about the techniques by improving the generalization. And regarding the implication, which is something important, basically, this model is suitable for real-time system. So, for example, a mobile or embedded development, and even a smart surveillance applications. And regarding the future scope slide, basically, starting with the extensions, we would like to evaluate an additional data set such as CK plus affected. There's also something called RAFDB, and also integrate the attention. Integrating the attention, basically the attention mechanisms, and transforms the layers. Then turning to exploring the multi-modal vision with audio and psychological signals. And regarding the limitation that we are having in our paper is a single data set focus. We are focusing on a specific data set, and then grayscale, low resolution constraints. And then finally, we are having limited training IPCHOS. And this is the only left in our slides. So, and those are the references as you can view it, that we focus on it in our conference of facial expression and emotion recognition slide. Yeah, that's it.
Okay, Aryan, nice work.
Thank you, sir.
May I ask a few questions?
Yeah, sure. Take your time.
related to your, what the source of data set in your paper?
Yeah. So basically, the data set is used, as I mentioned, it is FER 2013. Basically, it was introduced by the Lan Goodflew and colleagues from the ICML 2013 challenges in the representation learning. And the dataset is publicly available on Kaggle and contains 48 grayscale facial image categorized into 7 emotion classes.
You collected data from Kaggle.
Yes, correct.
Okay. How evaluate accuracy rate in your, what the parameter you have used to evaluate the accuracy of face recognition? Have you mentioned
Can
any
you
formula?
please, sorry, I didn't mention you. I didn't hear you. Can you repeat, please?
What parameter you have used to evaluate the accuracy? What parameter?
Okay, so actually, the model was evaluated using standard classification performance matrices regarding, for example, the accuracy. The primary evaluation matrix is the training accuracy. As I mentioned, it was 87%, around 87%, and the validation accuracy was around 70%.
How
And
you
regarding
evaluate
the loss function,
87% accuracy? Aryan, what I'm asking you understand?
yeah.
How evaluate to get the accuracy 87%? Which formula you have used to evaluate the accuracy?
Which what?
What formula you have used to evaluate the accuracy 87%? How you identify it is 87% accuracy?
Okay, get you. So the 87 refers to the training accuracy. It calculated using the standard classification accuracy formula. So the accuracy is equal to number of the correct prediction over the total number of prediction multiplied by 100. So basically it will be around the correctly classified images on the total training images multiplied by 100. And that's then we got the 87%.
Okay, nice. Have you mentioned comparison table also in your paper?
Compression?
Table. Where is?
Mm, yes, we include compression table to evaluate the model performance like against the existing CNN based on the dataset. So our model achieved approximately 70% validation accuracy, which is comparable to the standard CNN.
70% validation accuracy.
Yeah, we discussed the pattern with the prior studies in the discussion, like
Okay,
rather than presenting
but
a
it is
formal compression table.
very less accuracy rate, 70%. It's need to approx more than a 90% accuracy. It need be.
Yeah, you are correct.
Okay, need to focus how to improve the accuracy rate
Okay.
and mentioned comparison table also with existing methodology. How superior your methodology it should be described. I'm audible.
Yeah, so you said for me to improve, right?
Need to improve in your paper.
Okay.
How to its accuracy rate should be get more than 90%.
90%,
And
yes.
mentioned comparison table when compare
Yeah.
your proposed scheme with the existing methods also. How superior your
Okay.
methodology,
Perfect.
and mention some mathematical formula also.
Yeah, sure.
Okay, it's okay. Nice job.
Thank you very much, sir.
Okay.
There is no more presentation.
797, sir. Paper ID is 797.
Good morning. How are you?
Good
I'm
morning.
good. Good morning. I'm good.
Shall we start?
Please start. Please upload your PPT.
Okay, okay, don't worry, don't worry. Is it clear? Sir, is the presentation clear to you?
Yeah, yeah.
Uh,
Okay, you know.
Okay. So we would like to introduce ourselves, me, Mohammed Al-Araimi, and my partner Salah Al-Malki, and we had a third partner called, his name Khalid Lashmi. We are in computer science students in Modern College of Business and Science. So our topic was identification of important features in detection of insider abnormal activities dataset. It looks like a lengthy title, but we worked on a related paper. So as we know, it's kind of a very important issue. It is now getting or spreading between the organization. It may cost the organization a lot of loss, which is the insider caused by the insider threats. So our studies aims to identify the most informative feature or features related to the abnormal activities in the dataset. So to achieve this, we have identified, or to achieve this, we have used some common models like logistic regression, decision tree, random forest, XGBoost, and support vector machine. So we trained them and tested them again. So to introduce, I would introduce what is the meaning of insider threat. Insider threat actually are the employees or the users that have permission in the in the organization. So to mitigate this kind of insider threat risk, so what they did actually, most of the organization now they are using traditional techniques or methods, like for example firewall, which became insufficient to solve this kind of issues, or it is insufficient to solve this kind of issues or incidents. It's a real-time incident. So the data set that we have used or the related paper used, it contains many features which led to an increase in the time and the space, also space consumption. So what we have used actually to solve this kind of issue, we worked on this gap actually. We use feature extraction to help us to reduce the performance of the insider threat detection and reduce the computational cost, storage, and noise. So this is the actual gap that motivated us behind working this kind of project. So the literature review was about Al-Qawamshah. This is the paper of Al-Qawamshah and his partners. Their research papers focuses on real-time detection of insider threats. They have used a public data set from the CERT, which is actually a computer emergency response team. So this is publicly reduced because due to the limitation of this kind of data set.
Our methodology, large data set takes more space, more time. Our methodology to reduce the data set, to make it very small or small by select informative features or the most important feature and keep the accuracy same. Our results it's similar than similar to or similar to related paper, but with less the size of data set. We use same the data set, same classifier machine learning. After that, when we use that methodology, we select the important features. It's called score. We use this feature, and we create a new data set that contains risk score. Then we rerun the program again. Our results here in this page, and by using several machine learnings, we compare between us and related work. Support vector machine has shown the good result that we got if you compare between us and related paper in training time and prediction time. We achieve the same as their accuracy and results, but in a prediction time, training time, we got a perfect number when we compare between us and related work. The risk score summarizes the important behavior information and removing noisy features. You know, many features may be not important too much. Why we have to use just for make the data set too large or a big size. It's not a big deal if we delete it. We can leave most of features and use 2 or 3, or as we did as one feature. Then we can get a good results with small data set. Conclusion, risk score is the main feature reduction, improve efficiency, reduce noise. This model help us to focus on how can we decrease the size of data set and keep the result the same. Just in summary, feature scope, apply real world data. Maybe we work with another organizations that we help them in this side. You know, there are many of classifier environments and organizations that needs like these systems. We can improve our project in the future. This is our references.
Thank you very much for listening and having our paper.
Okay, Aryan,
Yes.
your work is nice. What the source of your data set in your
Same
paper?
data set.
Sorry?
The data set is same of related work. We use same data set.
Collected data from which?
Hmm?
You have collected data from where?
Related work use scientific data set because of the
Limitations.
unlimited, you know, this data is not available. It's very
Secure or
secure,
private.
private. No one can use real, but it's similar to the scenario of real life.
What methodology you have used? Decision tree, random forest, or SVM? Which one? Or you have integrated all these 3 methodology?
5, actually 5.
We used 5.
5 methodology you have used.
Yes, by using the decision tree, random forest, LR, XG post, and SVM. LR is logistic regression. means.
Now, all 5 methodology worked and worked.
No, not 5 methodology. It's just one methodology. Our methodology is use machine learning classification to find the important feature. Each machine learning or each algorithm has own strategy or on method. Like for example, decision tree use entropy, which the feature has more entropy, that feature is more important.
And you have mentioned your accuracy rate is 99 to 100%. It means no need to work further. You already got the
Yes.
99 to 100% accuracy. It means there is no need to research on further.
Maybe change the kind of data set, because our data set was little bit limited and lesser than the actual data set that the latest
Suppose
paper
you
worked
worked on data set 4,000, 5,000, yeah, something. You achieved 100% accuracy rate, then there is no need to work
we
further.
resample it again, we rerun it again.
What the parameter you have used?
When we create a new data set by important
What
feature,
parameter you
just
have
one.
used to get a accuracy rate? What parameter?
What do you mean, which parameter? Can you repeat the question again? I don't understand.
What parameter, what mathematical formula you have used to evaluate accuracy rate?
Okay. We used accuracy, precision, recall, and F1 score. Those are the parameters that we have worked on.
You have mentioned in your PPT?
Yes, it is mentioned here.
Where?
The results.
But you have mentioned mathematical formula, how to evaluate F1 score and all these stuff.
Yes, we have mentioned in the paper.
In conference paper, you can see.
Okay, this one is a review paper or innovative paper?
This is PPT. It's not conference paper. Conference paper we sent.
Is another paper. This is the only presentation for presenting. That's it.
Nini, your research work is review based or innovative based?
Review based. It is based on the literature review or work gap, certain gap.
Okay, Aaron, you work nicely. My few suggestions are key. You should mention your proposed methodology. What methodology basically you worked in your paper?
Already it is mentioned, but here just on the PPT, only summarized.
And
in conference paper we have wrote.
And second thing, how you have get 99 to 100% accuracy? How? Please check once again. Otherwise, no need to work further. Okay?
From 99 to 100.
100%. If you achieve accuracy rate 99 to 100%, it means no need to work further.
Okay.
So once again, you have to check it.
Okay, we check it many times. You know that data set related work, those people achieve same 99. When we rework, we achieved same, but we in the sample case we used less data set.
Reduced
the size of that data set.
Okay.
Small data set takes less time and less memory usage. Large data set takes more memory and more memory space. Our gap is to use less small data set to avoid of the time. The more time for training time to prediction time is real time. It's real time work. We have to use a model That
वो बोल
takes
रहे हैं कि
less
पेपर के
time,
प्रिंट आउट
not more time.
हर ट्रैक के पेपर का पूरा पूरा पेपर का
Okay,
प्रिंट आउट चाहिए,
ठीक है,
वो तो है ही
nice,
नहीं।
nice work.
Do you have
Print
any
check the
question?
thing,
Maybe
मैं इधर से
you
निकालना
सब पेपर का
you have
निकालना पड़ेगा,
more
वो बोल रहे
questions.
नेक्स्ट
No
सेशन के लिए
problem.
बोलेगा वो तो फिर अभी भी पहले इस सेशन का निकालना।
हाँ
Okay, Aryan, nice work.
Did you, excuse me, doctor, did you get our point?
Of course.
It's everything are clear or not?
Need some changes in your research work. Need to change.
Which
One thing you should mention how your methodology is superior compared to existing methodology. Need to mention in your paper
okay.
how your methodology is superior compared to existing methods.
Okay.
And need to work on more data set. Suppose you work on 5 or 10 data set, then your accuracy rate is higher. But when you put more data set, then what the accuracy rate? So you work on more data set also.
Okay.
Need to work on more data set.
Okay.
Right?
In the future or not, or now?
Sorry?
We have to, for this work, we have to rework or what?
Rework on more data set also.
Rework.
हाँ
Yeah.
सर हाँ अपने रूम में ऑनलाइन में बोलो
ठीक है? It's okay?
हाँ 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 वो अंदर हाँ
You
हाँ,
are
वो काम कर रहे हैं
management scholar? Are you? Are you management scholar or what?
Yes.
Okay, thank you. No problem.
Okay.
Yes, thank you.
Nice work.
Okay, I thank all the authors, all the 3 authors for making a valiant effort in presenting and putting up their points. I specifically thank Dr. Vijay Pallav sir for taking out his time at such a short notice yesterday
okay,
night,
sir.
and
Thank
really
you.
appreciate it. And
It's
I
my
mean,
responsibility.
and you have gone into depth of each paper and the points for each paper. I mean, should make a difference to the author. So the author should incorporate all the changes as suggested by Dr. Vijay. I mean, I understand these 3 authors also appreciate the comments that have been made by Dr. Pallav because they are writing it, and I think they were interested in knowing what were the suggestions. So thank you, Dr. Vijay. Thank you very
Thank
much.
you so much, sir.
And tomorrow again we will log in at the same time.
Sure.
Okay.
Sure, sir. Sure.
There will be 5 papers. And thank you, everyone. Thank you, Kazama, Aryan, and there is one more author.
Thank you, Mohammed
Aryan.
Mohammed.
Mohammed. Thank you.
Yes.
Thank you very much for joining in. Okay, and all the best
Thank
to
you
you.
very much. Thank you.
Thank you.
so
Thank you
much.
so much,
Thank
sir.
you, Dr. Vijay. Thank you all.
Thank
Bye-bye.
you.
Thank you, Dr. Vijay.
May I leave now, sir?
Yeah, sure.
Okay,
Dr.
thank you.
Arvind Mishra, please close the session. It is over.